first of all, according to question, find the Thevenin and Norton equivalent at terminal AB of the circuit. Okay, so AB, A and B. So first of all, our motto, determine Norton and Thevenin's equivalent. So first of all, we focus on Thevenin's equivalent. Okay, Thevenin's equivalent. We are focused on Thevenin's equivalent. I know that according to Thevenin's equivalent theorem, a linear bilateral network can represent like any terminal AB, that is A and B, you can represent, that is RTH and VTH. RTH and VTH across AB. Okay, so first of all, we are focused on VTH. How can we determine VTH? If you want to determine VTH, so first of all, removing, if suppose that a load connected here, then load is removed. Okay, but here load is not connected, that's why no any circuit is removed. Okay, or you can say no any parameter are removing. So first of all, we determine VTH across AB terminal. Okay, how can we determine? First of all, this circuit is given like this one, this one, this one. With the help of source transformation, you can also convert it. With the help of source transformation, this circuit is also converted. I know that what is the source transformation, I have already discussed. If direction of current like this one, a parallel resistance are given, R, here current I, then with the help of source transformation, XY terminal, this is also converted resistance, and if direction of current upward, then upper is positive and lower is negative terminal. Okay, and this is V this equal to IR, and what about resistance? Resistance is R, and that is XY. Okay, with the help of this theorem, this transformation you can apply here. If you apply here in this phenomena, then we converted it. First of all, remove the circuit. That is direction of current going on upward, so plus minus, and what about resistance? That is 6 ohm, and 1 into 6, that is 6 volt, and minus plus, that is 14 volt, and here 14 ohm, and 3 is this one is also converted. 3 into 5, resistance is 5 ohm, and if this one is converted, 3 into 5, that is 15 volt. What about direction of current? Is downward, so lower terminal is positive and upper terminal is negative, and that is A and that is B. Clear? Now our motto, determine voltage across VTH, means AB. So our motto, we are focused on VTH. So first of all, apply KVL in this loop, determine current in this circuit, and after that moving here. Okay, apply KVL another way, and we got VTH. Okay, so first of all, with the help of KVL, suppose that a current I, direction of current like this one, so positive negative, and current direction, so positive negative, so minus to plus, apply KVL, apply minus to plus, minus 6 volt, minus 14 volt, plus 14I, plus 5I, minus 15 volt, plus 6I, this will be equal to 0. So 6 plus 5, 11 plus 14, that is 25, that is 25I, this will be equal to 29 plus 6, 35, that is 35. So I, this will be equal to 35 by 25, 7 by 5, that is 1.2 ampere. Okay, so first of all, if any doubt, then recheck again, because of if any mistake, then going to 0 marks. So 6 plus 14 plus 15, that is 35. Clear? Now 14 plus 5 plus 6, that is 25. Clear? So 35 divided by 25, we got 1.4. 1.4, okay, ampere. So finally we got the current I, this is equal to 1.4 ampere. Now apply KVL in this loop. Minus to plus, minus VTH. Direction of current positive to negative, so 5 into 1.4 minus 15, this is equal to 0. So VTH, this is equal to 15 minus 5, sorry, if VTH is going on here, then minus 15 plus 5 into 1.4, so minus 15 plus 5 into 1.4, that is 7, so minus 8 volt. We got 8 volt. Procedure is same, maybe answer is different. Okay, so VTH, we got VTH, that is 8 volt, sorry, minus 8 volt with sign. Okay, 8 volt. Clear or not? Very clear. Direction of current like this one. So 5 into VTH, this is equal to 5 into 1.4, that is 7, and minus 15, we got minus 8 volt. So VTH is, we got minus 8 volt. Now another way, we focus on RTH also. How can determine RTH? So first of all make it, after that we focus on RTH. Okay. If you want to determine RTH, then I have already discussed. If you determine RTH, so all independent source are reduced to be 0. If voltage source, independent voltage source are available, then voltage source behave as a short circuit and independent current source behave as a open circuit. So this one is open circuit, this one is open circuit, and this one is a short circuit. So first of all make this circuit, that is 12 ohm, sorry, that is 14 ohm, and that is 6 ohm, and that is 5 ohm, and that is A and B. Okay, this is short circuit. If you want to make open circuit, and this one is also open circuit. Okay, clear? So open circuit terminal removing, and this one is also removing. Our motto determine RTH. So how can determine RTH? This one and this one are series. So 14 plus 6, that is 20. That is 20. That is 20 ohm, and that is 5 ohm, and A and B. So what about RTH? RTH is 20, both are parallel, so 20 into 5 divided by 25. So 5 and 5 4 ja, so 4 ohm. Okay, that is finally we got RTH is 4 ohm. And what about VTH? VTH we got minus 8 volt. What is the meaning of this one? So first of all converted, I have already discussed AB terminal means this is VTH and that is RTH. A and B and VTH. VTH is got minus 8 volt and RTH is got 4 ohm. Okay, or you can say that this circuit also represent like minus terminal is upper and lower is RTH represent minus 4 ohm and VTH is 8 volt. If you plus minus sign interchange, then this is positive. Otherwise, if you want to represent like this one, then it is written minus 8 volt. Otherwise, plus 8 volt. Okay, clear or not? This is Thevenin's equivalent. This is the Thevenin's equivalent across AB terminal. First of all make it, after that we have focus on Norton equivalent. Okay, make it, first of all make it. So finally representation of minus plus and RTH, that is A and that is B. VTH is written as 8 volt and RTH is written as 4 ohm. Clear or not? Now another way we are focused on another type, Norton equivalent. So first of all written here Norton equivalent. Norton equivalent. How can represent Norton equivalent? I have already discussed. If a linear bilateral network can be represented like, I have already discussed Norton equivalent. What is the meaning of Norton equivalent? AB, and suppose that load is connected here, then this circuit is also represent, that is Norton current IN and that is RN. Okay, if load is connected then also this here. Okay, otherwise open. Otherwise if load is connected RL then also connected here, otherwise if load is not connected then it is behave like this one. Okay, so our motto determine RN, IN and RN. RN and RTH both are same thing, same procedure. I have already discussed. If you determine RTH, then first of all assign a terminal. Our terminal is AB, and after that all independent voltage source and current source reduced to be 0. If independent voltage source are available, that is short circuited, and if current source are available then it is behave as a open circuited. Same procedure in RN also. So what about RN? RN is equal to RTH, so this is 4 ohm. So our motto determine IN. Okay, so how can we determine IN? So first of all make the circuit. This is and that is 6 ohm and that is 1 ampere, and this one is minus plus 14 volt and that is 14 ohm, and this is 3 ampere and this is 5 ohm, and this behave as a short circuit, ISC. Okay, our motto determine ISC. ISC is the equal to IN. So how can we determine ISC? Okay, AB according to Norton theorem, if determine IN then AB is short circuited. So if this one is a short circuited, no current flowing through 5 ohm resistance. Why? Because no voltage available here, 0 voltage. So 0 divided by 5. What about current? IN is 0. So no current flow here. In 5 ohm, no current flow here. So 5 ohm, what about current? It is 0. Clear or not? No current flow. It's behave as a dummy resistance. This resistance behave as a dummy resistance, useless for this circuit. Okay. Now focus on. So clear? Why no current flow in 5 ohm resistance? So if you remove here, so first of all this one is removed. Okay, because of it is useless, that's why it is removed. Clear? Now our motto determine ISC. How can we determine ISC? Now this current and this current flowing, sum of this current and this current, 3 plus ISC, that is 3 plus ISC, because if you apply KCL, incoming current 3 and ISC, so outgoing current here, that is 3 plus ISC. Okay, sum of both current are going on downward, so sum of this current is 3 plus ISC. So this current going through here, same current 3 plus ISC. Now 1 ampere current here, 1 ampere current here. So what about current in this circuit? Our motto, what about current in this circuit? 6 ohm. If you know any idea about that, is suppose that IS, the algebraic sum of this current, this will be equal to, or you can say that outgoing current ISC plus 1, this will be equal to incoming current 3 plus ISC, sorry, IX plus 1. So ISC, IX, this will be equal to 2 plus ISC. So IX is 2 plus ISC. Now apply KVL in this loop. Positive, negative, positive, negative. Okay. So first of all, determine apply KVL. Minus plus to minus, that is plus 6 into 2 plus ISC, minus 14 volt plus 14 3 into IS. Okay, voltage across this one is 0, so voltage across this one is 0. So if you apply here, then no voltage drop here, so this will be equal to 0. Now 6 into 2, 12 plus 6 into ISC minus 12 plus 14 into 2, 42 plus 40 plus ISC, this will be equal to 0. So ISC, that is 20 ISC, this will be equal to 2 plus 2, 4 plus 1, 5, minus 1 second, if this one going on here, and that is 40. So ISC is 40 divided by 20, that is minus 2 ampere. Minus 2 ampere. Clear or not? So if you want to make circuit, then IN this will be equal to ISC, and this is minus 2 ampere. Minus 2 ampere. And what about resistance? RN is 4 ohm. So Norton equivalent, make like this one. Okay. What about current? Minus 2 ampere. It means actual representation of the current is downward, and resistance, that is 2 ampere, and RN is 4 ohm, terminal A and B, and that is IN. Okay, make it.